Let's dive into Story Framework's save system. So opening up the content browser, inside of the Story Framework folder, we can find the save game folder. Here we will find our save game object. So inside of this save game object will be all of the values that are stored, saved, and loaded at specific times during gameplay. So for instance, we have our player transform inventory, the player's control rotation, etc, etc. After that, inside the blueprints folder, inside components, we have the SF5 manager actor component. So this is the actor component that gets attached to our player controller blueprint. Inside here we have an autosave function, our save game function, and our load game function. Inside save variables, we are saving player data and saving level data. Then we are saving that game to our save game slot. So we split our save variables into these two sections, just for easier readability and future reference when coming back to our save manager. Same thing with the load, we load the player data and level data from our save game slot. So we're going to go ahead and dive into setting up custom values to save and load. So inside our save game object, we're going to demonstrate this with a vector 3D value. So we can go ahead and add a new variable here. We'll call this example location. We'll set this to a vector and hit compile. We can just drag this into these save variables. Compile and save. Now we can minimize this. We're going to set up a little interactable object example for this demonstration. So let's go ahead and find our interactable base object in our content browser. With our interactable base selected, we can go ahead and create a child blueprint class. We're not going to name it or anything, this is just purely for demonstration. Go ahead and drag this out. Let's give this a cubic mesh. Let's do the SM cube. What we're going to do is we can give this a name and a simple prompt text of change location. Very simple. We can leave everything pretty much default here, as we're just using the default interaction method. Let's go ahead and edit this interactable. We can right click on our interact with BPI function and implement event. So off of the event interacted with, we can do a get actor location. We can then break our vector. We can search for a random float in range. We'll do a minimum of -15 and a maximum of +15. We can then add this to the Z of our vector. And then finally we can do a set actor location of this actor of itself. We can then make some space and search for a make vector. Plug this into the Z and then connect the Y and X values. Let's compile and save. We can go ahead and change the prompt offset to be in a more centralized location, so we can quickly figure out the medium location or the middle location, which seems to be about 50 units. So we can just plug in 50, 50, and 50. Let's go ahead and test this now. As you can see, the location is being offset. We're going to change this to rather modify the X position, as that will be a bit easier to identify when we save and load. So let's hit compile and save again. We hit play. Our actor is now moving side to side. We can slightly exaggerate this. Let's do -50 and +50. So our actor is now moving. now going to save the location of this actor for demonstration purposes of the custom variables inside the save system. So for easier referencing, we're going to give this actor a tag. We'll just call this tag demo. We're going to reference this actor by getting its actor tag. Now back into the content browser. Let's go to core, or story framework, save game, blueprints, components, and save manager. Let's go into save game. This will be classified as level data, so we can open up save level data. On the end here, we can reroute our save game object pin and search for a set example location. So this is the variable we created inside the save game object earlier. We can set that example location, and we can get all actors with tag. We can get the first index, as there's only one actor with this tag. We call that tag demo. We can then get actor location, and then we can just simply plug this in here. Again, this would be your own information. This is just a demonstration. So let's plug that into our example location. Now we are setting that example location variable. Let's go ahead and load it. So it's going to be a similar practice. We can copy the get all actors with tag and the get first array index. In load level data. Off of the end, again, we can reroute our save game object, get the example location variable, get all actors of class, and then we can do a set actor location. And then we can use that example location as the actor's location. Let's compile and save. Go ahead and test this out immediately. We go ahead and interact with our cube. Let's try to get it to a location that's identifiable. What we can do is move this cube a little bit further into this tree line, just so that we can see where it's getting offset to. Let's try and move it away. So our actor was initially in between these two trees. It's now to the right. Let's hit pause, save and quit. And if we continue and load our game again, our actor's location is being saved and loaded. So we can do this again. Let's try to get this to a different location. Now it's much further away from these trees. Again, save and quit, and we'll see that our location is still being updated. So it's a really simple workflow, but can apply to any variable and any actor. Anything you need to save can very easily be saved and loaded by following this process. While we are on the topic of saving and loading, I'd like to briefly talk about saving interactable object states. So when we have a custom interactable child created, we can also utilize the load from the event load from data string. This event gets called for any interactable in the level and is given a data string value. So let's go ahead and demonstrate this. We have a simple setup that we demonstrated earlier for saving the actor's location. We're going to set up something a bit more straightforward. Let's do a set actor location again. We're actually going to, so we're going to keep a similar setup here. This time we're going to flip-flop between two different locations. So for instance, let's do a flip-flop. On the X, we can then add. Off of the value, we can do a select float. These blueprints might not be the tidiest, I do apologize, but this is just for demonstration. So let's go ahead and make us some space here. We can connect the is A into the pick A. We'll do 50, or we'll exaggerate it. We'll do 100 and negative 100, and plug this into the X. Then off of the A, off of a self-reference, we can do a update. We can call the update interact actors save game function. This is essentially giving this interactable actor a state, a data string state. So into the A, we can connect this up. Again, we'll do a select string, and connect the pick A into the is A of the flip-flop. On A, we'll do positive. On B, we'll do negative. So now we have our different states. When we load, we can do a switch on string, and we can add these states into the switch on string. So positive and negative. Now again, we're just going to copy over these nodes over here. We're going to plug this into the positive. And since this is the positive state, we'll add 100. We'll add positive 100. And again, just copy and pasting. You would neaten this up a little bit. This is just a dirty example. On the negative, we would add negative 100. So we have our states. We have saving our states. Let's compile and save. Let's quickly remove the example location variable and saving and loading that into our interactable example actor. So inside the save as well, save level data, we can remove this. Hit compile and save. And go ahead and test this, making sure that our actor is swapping between two locations. So that would be positive, and negative. So in the positive, we can hit P, save and quit, and continue, and that state has now been loaded, which is the positive 100 on the X. Again, this isn't storing the state of the flip-flop. You could do that as well, but for this demonstration, we're just saving the state of the location. So let's exit and hit play. Let's now hit positive, back to negative. We hit save and quit, continue, and now the location has moved negative 100 units, because when we are loading the negative state, we are minusing 100 units. So you'd obviously set this up in a way that works in your situation, but this is just a brief explanation of saving and loading actor states. Another example of this can be found on the monitor. When we insert a cassette, we are saving the states of on or off. So when the monitor is on and we continue, the monitor stays on. When it's off, we save and exit, the monitor will be off. If you have any further questions regarding Story Framework Save System, be sure to either leave them down in the comments, or you are more than welcome to message me or message our community on our Discord. But that just about covers the entire process. Enjoy the rest of your day. Peace.